Okay, so we're back on part 4 of section 9.4. So this time we're looking at partial fraction decomposition where Q of x has non-repeated irreducible quadratic factors. Okay, so maybe some like x squared plus 3 or something like that, you know. So it's going to be not some irreducible quadratic factor. And so what we're going to do is we're going to have to first factor Q of x as much as possible because, you know, we're going to get to the point where it's not factorable and we still have some kind of x squared there. Then we'll use variables a, b, c, and so on to get all the needed items for the number of factors of Q of x. And so as long as it's a factor that just has a simple a to the first power, we can just put a. Now, if we have, you know, another one, then it would be b, and another one would be c. But now what's going to happen is after the ones that are not quadratic are finished, then we start taking care of the quadratic ones. And with the quadratic ones, what we're going to have to do is we're going to have a b times x plus c. So we're going to have two pieces here. So whenever you get a quadratic piece that's not reducible, it goes down here, and then we have a bx plus c on this. Now, if you have a second one, then it would be a dx plus e, and you just keep going and going and going until you have whatever value it is, and it was hard to determine what that would be. So with n's, you just have your a sub n, so whatever your variable is up to that point, that's what you'd use. So, you know, if this is y, x plus z or whatever, okay? Then we're going to do the same thing we've done the rest of the time. So the rest of the times is the part that's the same, is how we set it up for what kind of factor we have in the denominator. And so again, we're going to multiply both sides of the LCD by the both sides of the equation by the LCD to eliminate fractions. We're going to expand the left and right sides, and then we're going to set our coefficients of like terms from the left side equal to those on the right side to get the system of equations to solve, okay? And then we just plug it back in. And so our A will go here, whatever B is goes in front of the X, C goes to the right plus it, and then D and E and so on. So you have to kind of remember how the problem worked there. All right, so this one, again, they're really being nice. This one's factored. We can't factor x squared plus 1 any further. And so we're going to break that into a over x minus 1. Again, the non-quadratic part, we just have an a. Plus, now this one's the quadratic part, the x squared plus 1. And so that gives us the bx plus c. Now, if we had another term here, then it would be dx plus e over whatever that term was. But we don't have any more, so we're done. And so now we multiply by our LCD, which is x minus 1, x squared plus 1. So when we multiply on this side, we get 5x squared minus 6x plus 7 equals. Now the x minus 1 cancels, and we'll have a times x squared plus 1 plus, and here the x squared plus 1's cancel, so we'll have bx plus c times x minus 1. Okay. Now here we have a FOIL we have to do. Here is just a distribution. And so we get 5x squared minus 6x plus 7 equals ax squared plus a plus, now we have bx times x, so that's going to be bx squared. Bx times negative 1, so it's a minus bx. C times x, so it's a cx. And c times negative 1 is negative c. Okay. So now we have an x squared term, an x squared term, an x squared term. Now let's change colors. We have an x term, an x term, an x term, and one last color. I don't know, let's do green. And we have a number, we have a number, and we have a number. Okay. So we're going to have basically 3 equations and 3 unknowns. So to start with, we'll have a 5 equals, and then we have a plus b. And then we'll have a negative 6 equals, and then it has a minus b plus c. And then we have the 7 equals, and then we have an a minus c. Okay. All right. So what do we want to do? Well, this one gets a little more tricky. We kind of have to add 2 things together, it looks like, because if we add these 2 together, that will get rid of the c's. But then we'll have an equation with a and b, but then we can take that equation and work with the first one. And so this is going to be one of those where you have to do multiple steps to kind of go, I guess, where you want to get to before you actually get to where you need to be. So I'm going to take these two and add them first. Add first. So when I do that, I have 7 minus 6 is 1. Then I have A minus B. Our C's cancel. Now what I can do, if I look here, I can add those two. So I can add second. Okay. So if I do that, I have 5 plus 1, and that's going to be 6. Then I have A plus A is 2A. B minus B is 0. And so divide by 2, and A is equal to 3. Okay, so that's how I got to my A. Now I would go probably back to the original one here and solve for B, just because if I solve this one for B, I've got a negative and I'll have to change signs. So I'm just going to do it here. And so 5 equals 3 plus B. And so minus 3 minus 3. And so B equals 2. And then I also can plug it in for this one maybe and get my C. And I get a minus 6 equals a minus B, so a minus 2 plus C, add 2, and C equals a negative 4. Okay. So now I've got my all three terms here. We have the A, the B, the C, and I can plug in the A, the B, and the C. And so if I just write the fractions on the right side instead of repeating that first part, A I got was 3 over x minus 1 plus B, which was 2 times x, plus C, which is minus 4. And then that's all over x squared plus 1. Okay. So the trick to this one was if it's not factored, you have to first factor it. And then notice that this can't be factored, so it's a non-reducible quadratic. And then you set it up in a format like this, and then just work your way through and solve the system of equations. And then when you get done, plug it back into your setup as you set it up here, and you'll have your partial fraction decomposition. All right, so that's into part 4, and I'll be back with part 5 with more of those.